Are you crying? There's no crying. There's no crying in baseball!
We had started doing trigonometry and geometry last year, and we kind of extended these definitions to trig functions of pretty much any angle, not just angles inside of a triangle. Now the 6 trig functions you should be aware of are the sine, cosine, and tangent. And remember, for determining what these functions do, is that every trig function pretty much takes an angle. So sine, for example, takes an angle measurement and gives you back a ratio of sides. So it's sine, whatever the trig function is, takes an angle and gives you back a ratio. Now to determine for these basic ones what they do, remember the SO, CA, TOA. Sine gives me back the ratio of the opposite side of the hypotenuse. These are all dealing with right triangles. So if this was my angle measurement, which is x in this case, this is a right triangle, this would be the opposite side, the adjacent side, and here's the hypotenuse. So sine gives me back the ratio of the opposite side divided by the hypotenuse, cosine the adjacent over the hypotenuse, and tangent the opposite over the adjacent. Each of these 3, we're new this year, are the reciprocals of these. So cosecant gives me back the hypotenuse over the opposite, since it's the reciprocal of sine. Secant gives me back the hypotenuse over the adjacent, and cotangent gives me back the adjacent over the opposite. So it's the reciprocal of each of the 3 basic trig functions. We also looked at in each of the 4 quadrants whether or not these trig functions are positive and negative. And remember the acronym, all students take calculus or a smart trig class, where all trig values are positive here. Here only sine and its reciprocal value. Here only tangent and its reciprocal value. And here only cosine and its reciprocal value are positive. So these are where things are positive. Your sine is positive, your tangent is positive, your cosine is positive. So the first one, evaluate sine, cosine, and tangent of each of the following angles. 240, the first thing I need to do is figure out which quadrant 240 is. So let me draw in some reference points for myself. I know this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees, one full revolution. Now 240 is between 180 and 270, so I'm going to be somewhere in the 3rd quadrant. And I need to figure out my reference angle in order to figure out sine, cosine, and tangent of this without using a calculator. Well, 240 is composed of 2 parts. This part, which is 180, and then this part, which makes up the rest of the angle. Well, 240 minus 180, which is this first part, would give me 60, which means that this portion of the angle is 60 degrees. Now that is my reference angle, because reference angles are always measured to the x-axis, which is here. So this part was 180, and then when I go another 60, that's 240 for my total angle, so my reference angle is 60. So this is my reference triangle, which tells me since this is 60 degrees, this would be 30 degrees, which makes my hypotenuse, this is a 30, 60, 90 special right triangle, makes the hypotenuse 2, the side across from the 30 is 1, and the side across from the 60 is rad 3. So it's a special right triangle, which tells me that sine of this 240 degrees is going to be opposite over hypotenuse, which is square root of 3 over 2. You recall also that early in the year I had you memorize all of these special angles, the 30, 45, and 60. Had you remembered that, you would have known right off the bat it was square root of 3 over 2. But keep in mind that in the 3rd quadrant, it's A, S, T, C. Only tangent is going to be positive in this quadrant. And if you look at this reference triangle, you can see why, because this rad 3 is down rad 3 units, and this 1 is back 1 unit. So I really have negative rad 3 over 2, which is what's giving me this. So sine here is negative. Cosine of 240 degrees. Cosine will be the adjacent, which is negative 1 over 2. And tangent of 240 degrees will give me rad 3, negative rad 3 over negative 1, which is just square root of 3. So there's my 3 trig functions for this angle. I'm going to clear this so that I can do the next one, clearing from page. Okay, so the next one, beta, is 5 pi over 4. So now this is in radians. So I'm going to draw my reference in radians. Here's 0, pi over 2, pi, 3 pi over 2, and 2 pi. There we go. So now 5 pi over 2 is really 1 1/4 pi. If I write it as a mixed number, and 1 1/4 pi will put me here in the 3rd quadrant. Now just like before, this was 1 pi, so now I'm going an additional quarter pi, so my reference angle is pi over 4, or 45 degrees. Now, Rather than drawing the reference triangle this time, I'm just going to write sine of pi over 4. Again, I'm in the third quadrant, so I know that only tangent is going to be positive. So this will be negative sine of pi over 4, negative cosine of pi over 4, which is my reference angle, and positive tangent of pi over 4. Okay, so pi over 4, which is 45. I know offhand is the square root of 2 over 2 for sine. It's the square root of 2 over 2 for cosine. And for tangent, it's 1, and since tangent's positive, it's positive 1. So here are my three values for 5 pi over 4. So again, I wrote it as in terms of its reference angle, and I counted for the sine based on the quadrant I was in. So for the last one, negative pi over 2 is theta. Well, recall that a negative angle is going to go back. So I'm going back 90 degrees, which will put me here, which is negative pi over 2. Well, when we have a quadrant angle, which is one that doesn't end up in a particular quadrant, but rather as a reference, recall we think of it in terms of the unit circle. So the coordinate on the unit circle here would be 0 in the x direction and negative 1 in the y. Well, any point on the unit circle can be written as cosine theta sine theta. So the two values I'm getting off my unit circle at this angle is cosine of theta is 0, sine of theta is negative 1, and tan, which is sine divided by cosine, is negative 1 over 0, which is going to give me an undefined value. So there are my three values at this quadrant angle. So whenever you have a quadrant angle, you're not going to find a reference angle like we did with these other two, but instead you need to know what those values on the unit circle are in order to write them. Okay? Now, and rather than asking just the angle, I can give you a particular value. In this case, I asked you to find the 6 trigonometric functions if the terminal side of an angle passes the point 3, 4. So what I'm going to first do is draw coordinate grid. So here it will represent my y-axis. Here will represent my x-axis. Now I'm going to sketch my point on here. So it's at 3, 4, so that'll be 3 in the x direction and down 4 right here. I'm going to draw a reference triangle. So there's my terminal side of my angle goes to here. I know in this point I have gone down 4 units in the y direction, and I've gone over 3 units in the x direction. And since the x and y values are always perpendicular to each other, I know there's a right angle. Notice it's a 3, 4, 5 special right triangle. So I know these three values, so now I'm going to find sine of my angle. Now my angle is the reference angle, which is formed at the point of the origin, which is here. So sine of this angle is negative 4 over 5, opposite over hypotenuse. Cosine, again, if you recall, SOHCAHTOA. So sine is opposite over hypotenuse. Cosine will be the adjacent side 3 over the hypotenuse, so that's 3/5. And tangent is opposite over adjacent, so that'll be negative 4/3. Then I have wanted all 6 trig functions, so I need to do each reciprocal. So cosecant of my angle will be negative 5/4. I'm putting the negative in the numerator because that's the standard position. Secant of theta will be 5/3. And cotangent of theta will be negative 3 over 4. Okay, so there's my 6 trig values. So anytime you're finding it given a point, plot the point, find the reference triangle, locate the reference angle, and then use the Pythagorean theorem, or if it's a special Pythagorean triple, you could fill in the values, but find all 3 sides and then set up your trig ratios. Okay, find the 6 trigonometric functions of theta given cotangent is 5/12 and sine is negative. Well, first I'm going to do a sketch of my axes, which I have here, and I'm going to recall that a smart trig class should remember when tangent and sine will be positive. Now, cotangent and tangent are positive at the same time. So if cotangent's positive, that means that I'm either in quadrant 3 or in quadrant 1. Okay, because it's negative in the other 2 options. So those I can eliminate. Now, since sine is negative, it can't be in the first quadrant because sine would be positive, which means I'm in quadrant 3. So I'm going to draw my terminal side with my reference triangle and my reference angle. Okay, now cotangent is 5/12, meaning that since tangent is opposite over adjacent, Cotangent is adjacent over opposite, so the adjacent side is 5 and the opposite side is 12. And noticing what quadrant I'm in, that'll be a -5 and a -12. Now this is a 5, 12, 13 Pythagorean triple. You could also do Pythagorean theorem, 25 plus 144 equals 169. Square root of 169 is 13, so you can get your three sides that way. And once I have my triangle, I can figure out what my other 6 values. I already have cotangent, so that I can cross off the list. In fact, I'm going to write in sine of theta, cosine of theta, and tan of theta is equal, and I'm going to write in their reciprocals, cosecant of theta, secant of theta, and cotangent of theta. One of these I already knew. Cotangent was given me 5/12, and without actually doing any of this work, I could have answered this portion of it at least. The reciprocal function tangent would be 12/5. However, I did have to figure out the rest of this information in order to answer the rest of these questions. So sine is opposite over hypotenuse will be -12/13. Cosine will be adjacent over hypotenuse will be -5/13. And cosecant and secant are the reciprocals of each of those, so it'll be -13 over 12 and -13 over 5. So there's my 6 trig functions.